Okay guys, so here is going to be part 2 of our notes 8.1. So part 2 is going to be us going over these shortcuts that we have for solving these similar right triangle questions. So anytime that you have an altitude drawn into the hypotenuse of a right triangle, we can use both of these theorems to find missing side lengths. So the first one that we're going to look at is pretty much just known as your altitude theorem. So this theorem basically states that in a right triangle, the altitude from the right angle to the hypotenuse, what that does is that divides the hypotenuse of the big triangle into two segments, right? Here's segment A and segment B. So that altitude is basically splitting the hypotenuse into two pieces. Now, what they're saying is that the length of the altitude, right, in this case, x, the length of that altitude will be the geometric mean of the length of the two segments, right? Which may not make a whole lot of sense here, but that's basically what's building our proportion here, right? Basically building our setup for problems that look like this, right? The way that I like to explain this that is a little easier to see visually is the altitude theorem is basically called your heartbeat theorem, right? And so the reason why we call it a heartbeat theorem is because if we follow the path of what a heartbeat makes on a heartbeat monitor, it'll basically set up our proportion for us, right? But keep in mind that this heartbeat only works whenever we're given a altitude or we're asked to find it. So I want you to pay attention to this proportion right here. A over x is equal to x over b, right? I'm going to walk you through the heartbeat path that builds that equation, right? So starting with the very left here, right? So anytime they're asked for an altitude, I'm going to start with the left piece here. This is A, right? So that's the left side of my equation. A, if I follow up as a heartbeat, now I have A over x. Now the heartbeat has to come back down, so now I'm looking at the second equation. Now this is x, and I go back up over B, right? So I'm going to do that again because it's kind of weird to follow at first, but again, the heartbeat path that I follow basically sets up our equation. So if I go in the path of a heartbeat, here is A over x is equal to, go back down, x over b. If you follow that path, it's going to set it up for you, right? And this heartbeat, you use this anytime that you're given an altitude or whenever they're asking you to find an altitude, right? And we'll see a problem that basically makes use of this here down below. So let's take example 2, which says to find QS, right? This should already be in your notes. So the setup, if you watch the video for notes 8.1, you should already know what the setup is going to be here, right? Let's pretend like we're doing this for the first time, and we're filling in the blanks that we know here. It says find QS, meaning that QS is unknown, so I'm going to call it X. Now, with these types of problems, you want to fill in as much missing information as you possibly can, right? If the bottom side from P to R is 30, right? So from here to here is 30. And I only want SR, then I'm going to do 30 minus 6, telling us that from S to R would be 24, right? And so now we see here that this problem is asking us to find X, which is the altitude, right? The altitude theorem that we just discussed essentially tells us that we are going to build our equation by following what a heartbeat looks like. So if I want to build my equation here, let's go ahead and start here. This would be 6 over X, so there's 6 over X, is equal to, when I go down for the heartbeat, that is now x over 24. And there's your setup, right? So that definitely is a lot faster than separating out all three triangles, highlighting, finding corresponding sides. This is intended for you to be able to work these problems a little faster, right? And so this video is just going through the setup. I know y'all know how to cross multiply, so there's your setup, and that should match up to what you had in the notes by separating out three triangles and setting up those corresponding sides. So that is your altitude theorem or heartbeat. The next theorem we want to take a look at here is going to be known as your leg theorem, right? So this leg theorem over here off to the right is going to be used anytime that you are looking for one of the legs of the large triangle as a whole, right? Or in other words, you're using this theorem whenever I'm not utilizing the altitude pretty much. So this leg theorem states that the length of each leg of the right triangle will be the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. Again, right, so reading that probably is not going to make a whole lot of sense. So thankfully, we have another kind of pattern that we can follow here. Now, this pattern is going to be following the path of a boomerang, right? So one thing you'll notice about boomerangs is they go forward and they come back around, right? And so let me walk you through what this pattern looks like. So looking at the first equation here, this one right here, the C over A is equal to A over X. The way that you do this boomerang method here is going to be, essentially, you're going to start at the hypotenuse of the big triangle every single time, right? Now, the path that you travel towards is going to be the missing leg length, right? So my missing leg length here is A. So I'm going to start at the hypotenuse and I'm going to travel towards A, right? And I'm going to walk you through how this sets up the equation. So starting at the hypotenuse, I'm basically here starting at C. So there's my C. As I make my way to A, there is C over A, this first part. And the boomerangs, they come back around, so now this is equal to A over X, which is the second ratio here. And so that's how the boomerang works. You work your way towards the missing leg and then wrap your way back around and stop at the hypotenuse piece X, in this case, the hypotenuse piece that is adjacent to your leg, right? So let's see that again in action, and I'll walk you through it one more time. So our boomerang here, again, if you're looking for our leg A, you're going to travel towards that direction. So we're going to start at the hypotenuse. This is C over A is equal to A over X, right? And that is building this equation right here. Now that works for both legs, right? Well, how does this work if my leg isn't the one on the left and it's the one on the right, like we have down here below? Pretty much the same thing, except I'm now not traveling to the left, I'm traveling to the right. What I told you just a second ago was that this boomerang method has you traveling towards the missing leg. So in this case, if I travel towards the missing leg, this would be C over B is equal to, wrap back around, B over Y. And there's our equation right there. So let's see that in action one more time. If we are traveling towards B to find that missing leg length, I'm going to start at the hypotenuse, C. That's C over B, and then wrap your way back around is equal to B over Y. So that's your boomerang method, right? It looks kind of weird, but essentially it's going to look something like this. Or going the other direction, something like this, right? So let's practice using this boomerang method to set up one of the equations in the notes that we've already solved already, so that we know what the answer is, we know what the setup should look like. So let's take a look at example 1. So that first example, we're noticing here that in this example, by altitude here is this red line QS. They didn't give me the altitude, and they didn't ask me to find the altitude. So if I'm not working with altitude, then I'm not using the heartbeat. Now I'm using the leg theorem. So this is your boomerang path that you're going to take. So I'm looking for the missing leg length of the large triangle X. So I'm going to travel towards it, right? And one thing you're going to want to be careful of here is, as you do this, you need to make sure that you know the entire length of the hypotenuse, right? 12 plus 2 gives me the length of the hypotenuse, of 14. So if I start my path along the hypotenuse, then as I build my equation, this would be 14 over X, so 14 over X is equal to, now I travel back down, and I get X over 2. Right? And so you should see that that setup for our equation is going to match up to what we had earlier in the notes. And just to reemphasize one last time, whenever you're doing these similar right triangle problems, you're going to notice that one of the diagonals repeat every single time. So my diagonal that repeats here is X. That's an indicator that you set it up correctly, right? And so again, I'm just focusing on the setup here for this part 2 of the video, right? And so just so that we can see both one more time, let's just practice setting up some problems in the homework, right? So taking a look at number 5, right? So for context here, you got 2 setups for the shortcut. You got your altitude theorem, which is your heartbeat, and then you have your leg theorem, which is your boomerang, right? And so if I take a look at number 5, they're asking me to find X. X represents the altitude. So I'm using this pattern here to build my equation. So if I do my path of an heartbeat here for altitude, then this would be 4 over X. Go back down in your heartbeat, X over 9. There's your setup, right? And we're not separating 3 triangles out, and I got my setup, I'm good to go, cross multiply, and get your answer. And I know I set this up correctly because remember I said earlier, your diagonals repeating is a sign that you set it up correctly. So now let's look at maybe one that uses the leg theorem. So let me go back to the homework here. So let's take a look at maybe one problem where they don't have the altitude marked. For example, number 6, right? Number 6 here, if I'm going to be using the leg theorem here, so the leg theorem has me looking for one of the legs of the large right triangle, then that means that I'm going to be using the boomerang method, right? Let me actually write that in parentheses here. So if I'm looking for a leg, then I'm looking at the boomerang path, which basically has you traveling across the hypotenuse and wrapping your way back around. So the thing I need to start with here is, well, what is the hypotenuse? Well, the hypotenuse is 20 and 25 combined, so that would be 45. So if I'm going to set this up following the path of the boomerang, you need to go towards the direction of your missing leg, which is x. So I'm going to travel this way. This would be 45 over x is equal to, wrap back around, x over 25. And my diagonals repeat, we're good to go, we set this up correctly. So this shortcut is gonna take some practice and some getting used to, so I would encourage you to try some of the rest of the problems in the homework and see if you can get these equations set up correctly. If you're having a hard time with these types of questions, the similar right triangles, again, please reach out to your teacher. If your teacher's absent or they're not available, reach out to me, Mr. Barbary. I have tutorials pretty much daily, okay?